Hey guys, before we move on, I know in the previous video I was talking about how we were going to move on to some of the interface-based configurations that are associated with EIGRP, but there was something else that I thought of that I wanted to make certain that I covered before we moved on that has to be considered to be far more fundamental to the operation of our protocol. Now, what we had in our environment was we have Cat1 and R1 running EIGRP named mode. All of the other devices that are connecting all the way up such that we're ultimately reachable to R22 in our data center are running just regular classic EIGRP configuration. Now, we were playing around with this idea of our rib scale and a number of other elements, but what I wanted to do before we moved on was talk about how EIGRP modifies the composite metric computation, because wide metrics work one way and classical metrics work the other with regard to performing these computations. Now, as you can see, I have a Wirecast session right here on our screen, and what I want to do is I want to look at a update, and what I'm going to do is I'm going to come under here under parameters, and I want to look at these K values that we were talking about in passing previously. We have K1 through K6. Now, what I want to point out here is that these are going to have dual meanings. So actually, let's see, I'll do this. The first meaning in red is going to be my normal operation. So in normal operation, if I just highlight this metric, notice down here it says it's bandwidth. So in normal operations, K1 is a coefficient used to modify bandwidth, and it's going to be 1 by default. However, in the confines of our wide metric computations, it's going to be considered to be throughput. Now also we have a variation on this theme with regard to K3. Now in the confines of K3, for normal calculations in EIGRP, classical EIGRP, this is a coefficient used to modify delay. However, in our EIGRP named operations, this is referred to as latency. Now, why am I bringing this up? Well, I'm bringing this up because in wide or in named mode operation, our composite metric is actually compiled by taking the throughput plus our latency. So as you can see, we're still using the same coefficients. 1 and 3 are on, therefore we're using bandwidth and delay for normal computation and throughput and latency for our wide metric computations. Now the problem is that this is EIGRP, so it's never straightforward. So what I'm going to do is I'm going to return to the whiteboard, and I want to mention some of the values that we need to understand and at least remember. So right now, what we have are some points, things I want you guys to remember out of the gate, and do not forget, please. That's going to be the value of our EIGRP constants. What are these constants? Well, the first one is considered to be the EIGRP bandwidth constant. That value is 10 million. The next one is going to be our EIGRP delay, and it's going to be 1 million, and it's also going to be in picoseconds, where 1 microsecond equals 1 million picoseconds. Hopefully we'll never have to worry about that computation. Now, the reason I'm pointing this out is because we're going to use this EIGRP bandwidth and this EIGRP delay constant to determine what our actual throughput is and our latency. Because like I said, EIGRP named operation utilizes throughput and latency, but it's not going to be that simple. We're going to have to do some mathematical computations to determine what those individual values are. And what I want to do is first entertain the basics. So what we're going to find here is this throughput. I'll go ahead and just erase latency. And I'm going to go ahead and take this pico out. And let's highlight what our configuration is for throughput. So what equals throughput? Throughput is equivalent to our EIGRP bandwidth constant times the number 65536 divided by my bandwidth. Let me fix that. 65536 divided by my bandwidth minimum. So the bandwidth of the slowest link in my topology. Now, that also means I need to understand how my delay is computed. Well, not my delay, it's my latency. Latency is equivalent to my total delay again, remember that's going to be in picoseconds times 65536, and all of that is going to be divided by my EIGRP delay in picoseconds. So that's the math. So when we start looking at this, let's find out how we actually compute the metric for a route in our topology. Let's pick one. Show IP EIGRP topology 172.16.2.0/24. And let's do some working values. I'll do my working values in blue. So right now we see that we have a metric that's going to be set up for the loopback interface of R2 of 172.16.2.0/24, and that metric is 459,407,360. Now, how did we derive this? Well, we derived this by taking our throughput plus our latency in accordance with these two formulas. So when we look at this, let's take a value and see what comes out. So let me grab my calculator so I don't make any mistakes here. Well, that implies I won't make any mistakes. It's been my experience that I normally make mistakes when and where possible. So let's embed this right here. So right now, let's go ahead and figure out what our throughput equals. So throughput, what we're going to do is we're going to take our EIGRP bandwidth value, which is going to be this value right here, which is going to be our 10 million. And what we're going to do is we're going to times that by 65535. I don't want to do that. 65536. We're going to hit enter. And then what we're going to do is we're going to divide it by our minimum bandwidth. Well, our minimum bandwidth is right here, and it's 10,000 kilobits. So let's say divide by 10,0,0,0,0. And what we're going to do is we're going to hit enter, and that's going to give us a value. Now let's take a look at this value. So I'll go ahead and write that in here. That value is 65536,000. Now all I want to do is I want to confirm this just to make sure my numbers are right. Don't want to get all the way to the end of this and realize I made a mistake. So I'm going to take my EIGRP underscore bandwidth value of 10 million. I'm going to times it by 65536. Then I'm going to divide it by my minimum bandwidth, which is going to be 10,000. And that's going to give me the value that I'd already computed. So I just confirmed and verified my math. It's 65,536,000 as that value. All right, now what we want to do is figure out what's going on with our latency. So in the confines of latency, what are we going to do? Well, we're going to take our total delay in picoseconds, which is this value right here. So that's going to be 601, 0, and then 6 zeros. 1, 2, 3, 1, 2, 3. So let's make sure that's right. Yes, it is. Then what we're going to do, we're going to times it by 65,536. Then what are we going to do? We're going to divide it by our constant, which is going to be 1 million. And that's going to give me a value of 65,536. Actually, I've got this all wrong here. 1, 2, 3, 536, 0, 0, 0, 0, 0, 0. Now what I'm going to do is I'm going to take these values and add them up. So I'm going to take my lower one and I'm going to add my second one to it. And it's going to give me 65,536, 0, 0, 0. Press enter. My math is all hosed up. That number should have added up to my feasible distance, which it did not. So what I need to do is find out what I did wrong. Let's just double check our math here. So we have our EIGRP underscore bandwidth, which is 10 million. Times 65536 divided by my minimum bandwidth, which was 10,000 kilobits. And that gives me 65,536,00. So that part looks right. So let's take our total delay in picoseconds. So that's going to be 6010. Then 6 zeros. 1, 2, 3, 1, 2, 3. Times 6536 65536. Divide that by 1 million. And that looks better. So let's see what we got here. Somehow I really screwed that number up. I apologize for that. So let's see what happens now. So I've got 393,871,360. Okay, this looks closer to the mark. So when I come up here and take 393,871,360 and I add 65 million, 536,000. So 65,536,000, and hit enter. Then I get a metric computation of 459, 407, 360. Sorry about the math mistake there, but they do happen, and this is why I want to make certain that you actually verify your numbers. I don't know exactly what I did wrong. I'll go back and watch the video and see, but you can witness here the fact that that's how we determine our feasible distance. The feasible distance is going to be that calculation, but notice here it's smaller, but again, remember that's because we're going to be dividing that by 128. So when I come up here and say divide by 128, by default, hit enter, that's going to give me my 3,589,120. So you just saw how simple, or admittedly, how complicated it can get trying to do these computations. Remember, you're going to have to remember those values. So when it boils down to it, remember, our EIGRP bandwidth is going to be 10 million. 10,000,000. And our idea of EIGRP delay in pico is going to end up being 1 million, 1,000,000,000. Then you're going to use those computations to actually calculate what our delay and what our latency and our throughput are going to be based on those formulas that we just discussed. And once you get that done, you'll have a perfect idea of how our wide metrics are going to be used to compute our feasible distance in an EIGRP named environment. Now with that said, I'm comfortable moving on to some other topics, and I'll see you guys in those videos. Bye-bye.